Hello, everyone. Glad to be here again this year. Today, I will talk about a little bit different software development concept that I like to call time-driven development. And as we already mentioned, this is not about building things without thinking about the implications that they would have just thinking about how to make it fast. It's about saving time on the long run by using the proper processes, whether it's making something more complex or making something more simple in the short term. So a little bit of background before we start. My name is Katerina. I'm co-founder of Adeva, which is an exclusive network of remote developers, and we partner with companies to help them scale their engineering teams. I'm also part of the Mozilla Tech Speakers Network, which is an amazing community spreading knowledge about all things open source. So as part of Adeva, I've had the chance to work with a variety of companies from startups to Fortune 500. And in those years, I've seen all the aspects of software architecture that these companies are trying to apply in the daily work. Sometimes it's coupled code, sometimes it's trying to improve the processes, but in all cases, the single most important metric for everyone is the developer's time and how to save more time so that we can focus more on the end users. And that's why I started thinking about time-driven development as a concept. And also, going through the internet, we constantly see things, people advocating for all these best practices, which are supposed to be best for everyone, like using TDD or solid design principles, or all these best practices for software development and design that we blindly follow without thinking whether they would actually make a point for us. So this is one example of these cases. Like this is Johannes, who was around a year ago. It was a very popular discussion on Twitter. He was following clean code so much, he wanted to make his code even cleaner all the time, that he spent so much time focusing on meaningless code, on optimizing it, cleaning it up, so that he would achieve this state of perfect code that's clean and that has the best developer experience. But he realized that that made him spend a lot of time on actually perfecting the code, that he didn't have enough time to focus on the users, focus on the value, and actually spend time with his family, as he says. So at some point, following these best practices actually brought frustrations for him instead of making his life easier. And then we have another example. This is about the solid design principles, where a team actually focused so much on achieving solid and achieving single responsibility principle that they fragmented their code so much that at the end, they just tried to refactor away from it. So when you get to a point where you think you have applied single responsibility principle, but you actually fragmented your code so much that it's unusable, it's unmaintainable, and it's not serving its purpose, then you realize that you have a red flag and you need to do something about it. So these are cases where we try to follow these principles without actually thinking whether they would bring us value or not. And thinking about where all this comes from, I ran into the obligation of the programmer. I think it was published in 2014 by Uncle Bob. And he says, as developers, our obligation is to be proud of what we did today. And that being using TDD or applying solid design principles or just fully testing our software, which we all know is impossible, just to come back home feeling proud of our achievement. And this is great. It's a great mantra to think about, OK, I need to do this because I want to be proud of what I accomplished at the end of the day. But it's not using these practices that should make us proud. It's developing something, building something that actually brings value to someone and makes their life easier. So when thinking about all of this, it's where the time-driven concept comes to mind. Because we've created a toxic environment that values following all these principles instead of actually bringing value to the users. In reality, we also have examples like this. So this is Remote OK, is a job platform for remote jobs, which is focusing on helping developers to find their remote job positions. And it's basically a single index.php file that was, this is a tweet from 2017. It's already been 2 years from then, so if it was generating $2,000 a day at that time, right now that number probably increased. And the architecture of that software is basically an index.php file. So I'm not suggesting that we should dump everything in a single file and forget about all these good practices about software architecture, but this is a great example about the context of the project and that we should think about it before starting to build our software. Trying to build complex architecture, trying to follow solid design principles in this example would actually make them spend a lot of time developing their code without having a use of it afterwards. So as I said, this is where time-driven development comes into the picture, and it's about finding this balance between dumping everything in a single file and then over-fragmenting your code and following clean code practices just for the sake of doing it. So to explain things a little better, I wanted to go through two specific examples that I faced with during my work at Adeva. So the first one is building Adeva's platform and building the features for the developers to set up their profiles. This is how that actually looks like. So when we were starting back in the days, we were more like an agency with a local team, and we were able to handle everything manually to be sure of all of the job positions that we have, all of the developers that we need to match them with. And we were kind of using Excel sheets and everything to have that into place. But once we started growing and once we started expanding with remote developers, we realized that we wouldn't be able to do that for much longer. But on the other side, we didn't want to spend a lot of time developing something that we didn't know it would be useful for us. And we didn't want to spend that time trying to create the proper software. Instead, we decided to go lean and use some existing platforms on the market. So for this, we decided to rely on CRM software, which was kind of like our database for storing all of the developers' details. It has their profiles, their previous experience, their education history, skill set, and everything that's related to it. And apart from this, we also have all of the clients that we work with, the job positions. Everything is handled properly by that CRM, and we're just connecting with it with an API and using it on our end to display everything nicely. So in the background, what this does is basically using this class, which has all of these methods for accessing the needed details for the developers, for the candidates, and then using it on our sides to manipulate this data. And all of the examples are in Laravel, which is a framework that we're using. But it's the whole talk is applicable to any language and any framework because it's more than about writing the code. So if you don't understand some specifics, that's fine. You should only focus on the general idea that this represents. So how this looks like in the controller, we have this edit method, which relies basically on this class over here for pulling all the data from the CRM storage. And then we are getting their experience, their education, pulling them in separate variables, and then passing it to the view afterwards. The two things that we should notice here is, this is the first one. So basically the controller knows too much about the implementation of everything, and it's open for modification. What this means is, going forward, we would like to switch to a local storage. We would like to create our own database for storing everything. So we wouldn't like to rely on the external CRM all the time. That would mean when we need to do this change, we would have to go back to this controller, change all of the logic and change all of the places where we access the external CRM with our local implementation. The second part is we know too much about how things are named on the CRM side. So this would mean, again, instead of using our own naming conventions, our own variable names, we would have to rely on this CRM. And if we need to change it at a later point with another CRM or with a local storage, we would have to adapt this and change this accordingly because of the new naming conventions that we have. So this is in this small method, we have a lot of changes already. We'll see how it looks like in a little bit. To check the view again, so there are two things to notice over here. Again, we depend on the actual naming conventions of the CRM system, so we would need to go ahead and change everything in all of our views. And also, the experiences is a separate variable that we are looping through to pull this data. When we switch to a local system, that would also look a bit different. These are basically the changes that we need to make. So going to a local storage instead of using the CRM, this is how the edit method would look like. We are using a user class that we already developed to connect to our local MySQL. And then we get the skills from those relations that we've established with the new database structure and returning the view. So you can notice that all of the basically, we deleted all of the lines of code in this method and replaced them with new ones. In the view, again, it's a lot of change going on. This experiences array at the beginning is replaced with an actual relation that we have in our database structure. So instead of accessing a separate array of objects, we are basically relying on the relation that we have with the experience. And this would scale a lot with the rest of the variables and of the data that we need to access in this view, because we have education, we have skill set, we have a lot of parameters that are needed over here. So let's see what it takes to change the storage. First, we need to create these models that are representing basically the objects for every data structure that we have in the database. Then we need to change all of the dependencies in our controllers to depend on our local structure instead of the CRM storage. We need to use that to pull all the data for the view. So again, in the view, we are adjusting everything accordingly to our new standard for storing the data. All of the variables need to be changed to the new naming conventions. We need to change the way we access the data in the view. So we were using arrays before, now we have objects, collections. So that changes the whole flow and introduces a lot of change in the views themselves. And finally, we need to adjust the unit tests for everything to work accordingly. And all of this is just for a single method with 5 lines of code. If we scale this to the other methods that we have, to updating the profile, the admin functionality that we have for storing all the details for the candidates, their jobs, their history, clients that they work with, it's a massive scale that needs to be completely changed. And it's not only about the time that we need to change all of this, it's having your code open for modification like that actually introduces a lot of issues going forward, because it's not tested enough. You are changing everything, so you are introducing possibly new bugs in the system, and you need to spend a lot of time in retesting everything and trying to make sure that it all works together nicely. And the time we needed to switch from the old architecture to the new one was actually a month of work. This is 30 working days that we had to dedicate to switching from the old storage to the new one. So let's see what we can do to save time by improving the design of this code. The first thing that we should do is to not depend on concrete implementations. What this means is introducing we decided to go with the repository pattern. So over here we have a repository interface for all of the methods that we need for pulling the candidate details from the database. And this repository interface, basically over here, it just outlines the main details about the candidate, but it also involves all of the experience details, all of the education details, skill set, and the relations with it would be introduced in separate repositories if they need to be accessed separately. So what we need to do is, for every storage that we will use, create a separate class that would implement this interface, and then based on that, we would make sure that the methods that we need to use would be implemented by the storage that we are using at the moment. In the controller, this depending on the abstractions thing is actually represented by using the repository interface as a dependency instead of depending on the actual CRM storage API. So, and over here, this is how we get all of the details about the candidate. So basically, we know that in this repository, the get candidate by ID method would return all of the candidate details together with their experiences, their education, skill set, and everything that we need for them. And then through that relation, we are again adjusting the skills accordingly and passing them to the view. The second part is to be mindful about what our program expects, because the biggest problem over here was in the views. We were using arrays to access all the data in the views at the beginning, and now we have something else. We have a different structure, and we need to go ahead and change everything that we had developed before. So to adjust for this, I've created this candidate class, and again, this mocks the relationships in Laravel that are represented through the models. So basically, in the candidate class over here, we have these three methods below that are giving us all the related details that we need. It includes the overview is mostly accessing the skills and related details for the candidate, but the bottom two are the education and the experience that are related to them. So now we don't need to use a separate class to access them. This candidate class has access to them already and will return all the needed details accordingly. And in the view, that would mean that now we can use this relation since the beginning to access all of the experience details for the candidate instead of trying to pull the data separately and use it as a separate variable. And over here, instead of depending on the naming conventions of the CRM, we can now depend on the structure that we've set up intentionally so that we can follow it throughout the whole process. And the third part is to bind the abstractions with the concrete implementation. So to have all this work properly, the thing we should do is in the service provider, we need to bind this concrete repository that implements all of the needed methods to this interface. So whenever we see the interface in the controllers, we would actually, the framework would instantiate this class in the background. Now this means when we need to change things, this is the only change that we would need to make. Yes, we would need to create new classes to add this code to function with the local database, but the only change that we need to make in the whole code structure is just changing this line of code to depend on a new database repository instead of the old CRM one. And this makes our code much more robust and resistant to bugs because we've spent a lot of time testing everything, and now everything that's tested doesn't get changed. We only add new code, and we only need to retest the new code that is added. Everything that was existing before will continue working without any further change. So take two, this is what it takes to actually switch the storage. First, again, we need to add all of the models to work with the local database. The second part is to create the new repository that would replace the old one for the CRM. And finally, change that binding for the candidate repository interface. And this is a structure that required a bit more time for us to set up front. So yes, it's much easier to just create a single API class, dump all the methods in there and use them as you need them. And it's much faster to set up at the beginning, but it causes a lot more, it takes a lot more time if you need to change things afterwards. With this, we had to spend around maybe twice as much to set things up at the beginning, but still it wasn't that long because it was a clean structure. And it took us 5 days to switch afterwards. So around 6 times less time to make the switch when we needed to do it. And in this scenario, it makes sense to spend that extra time at the beginning just because on the long run, it improves your whole workflow and it saves much more time to the whole team. Now, using this experience as an example, we wanted to do the same with another integration that we were introducing on the platform, and that was using GitHub profiles to actually pull developers' data and automate part of the screening. So to do that, we decided, okay, we need to be able to use GitHub, maybe GitLab, Bitbucket, other Git systems as we go forward, because yes, we want to be open for extension and we want to be able to extend and maintain our code quickly just because we learned that if we spend a little bit more time at the beginning, it will make things easier for us as we go forward. So we created this factory class that is initializing the proper Git profile depending on what the user has set up. It's using the type from the database, depending on the user, on the logged in user, and then initiating the concrete class. In this scenario, at the beginning, we just wanted to set up the proper architecture, but we didn't want to implement everything at start, so we only started with GitHub. Now, we have this abstract version control now, because if we are going to instantiate all of the classes dynamically, then each of them needs to comply with certain rules, right? And this is what we want to define with this abstract version control. So we have all of the methods that that every Git profile would need to implement, like searching repositories, searching users, getting all user details, and everything related to it. And then finally, for every class for every concrete class that we are going to have, we need to implement this interface. And another thing to notice over here is, again, we want to be mindful about what we are going to use. So since the beginning, we created this adapter class that would pull all the details from GitHub, but instead of depending on their naming conventions and their structure, they would just prepare everything for what we want to use and adjust it accordingly so that we can access it afterwards. So it took quite some time to create all this proper structure that would allow us to extend it afterwards. And this is how the controller looks like. So basically, we are using the version control factory to instantiate the proper class based on the type of the Git profile that the user has. And then we are using the methods that class has to access all of the user details that we need, passing it through the view afterwards for proper usage. Now, the thing is, we did this, we spent maybe 10 times more time because it was quite simple to implement it the other way around. But we did it because we thought that we would need to extend it at a later point, and we thought that we wanted to have a structure where we would be able to add new things as we went forward. In reality, a year after, we didn't even touch that code. We didn't even use what we had implemented for GitHub, let alone re-implementing it for other version control systems. So basically, we spent a lot of time at the beginning investing into something that we never needed to use. And it would be much, much better to implement things simply at the beginning, and then if we needed to extend it at a later point, then come back to it, refactor it, and add the new features that we need to do that. So what's the better way to implement all of this? As it turns out, this is the only thing that we need to do. So basically using a GitHub package that already exists for Laravel. I suppose there are a lot of packages for different frameworks and languages. And we are using the methods that they are providing for us. It's only 2 lines of code to get all of the details that we were getting before. And this takes maybe 10 minutes to set up and probably an hour to have everything tested and run through. What we did before, we had to iterate through it, test it, and create a proper structure without actually having to use it afterwards. So that brings back the question about why time-driven development. The first thing is that software design practices come with trade-offs, and we should know them so that we can be able to understand what makes sense for us and for the context of the project. In the first example, spending a bit more time at the beginning to set up everything right and to make it more extendable made sense because it saved a lot of time going forward, saved a lot of time for the whole team on the long run. But in the second example, we spent a lot of time at the beginning without actually knowing that we are going to use that as we go forward. So that's time that we spent upfront that we could have spent to create something more valuable for our users, or to try to understand or re-implement something else that have been in the backlog for a while. The thing with the software design principles is that they should simplify your life, not complicate it. So if you're faced with something that when you try to implement it, it only brings some more overhead to the team and requires some more time from you to go through everything and change things as you go forward, then it's probably a red flag and you need to think about it and try to understand whether you need to do it that way or not. The third thing is thinking about the bigger picture will help you create more than just a software. It will help you create value for everyone who uses it. Because if we were really thinking about what we would use from this GitHub integration and how it would help us going forward, we would probably decide to go with the simple solution at the beginning, and then if we need to extend it, just go back to it, refactor it, and add the new things. So how can we start practicing time-driven development? The first thing is to talk to your leads or to the product team. Try to understand what are the business goals before proposing an architecture. If you're certain that something has to change going forward, if you're certain that something needs to extend, or there are some things like we had with the storage that would definitely be changed in near future, then yes, definitely invest a lot of time into creating a proper architecture, use the solid design principles, use clean code, try to create a software that would bring better developer experience, but also make it easier for you to extend and modify in the long run. But if it doesn't, if it's something that you're testing right now, or it's a feature that you don't know whether you would use it afterwards or not, just spend the least time possible trying to create a simple solution and then go back to it and refactor as needed. The second thing, maybe most important, is to always keep the context in mind when designing software. We saw the example with the index PHP, we saw the examples with the overfragmentation in Solid. So these are things that you need to constantly keep in mind when choosing the design practices that you follow. And finally, don't shame others for not adhering to the best software development practices, because what's best for the context of your project doesn't have to be best for mine or for anyone else in the room. So again, the context and what it brings to the table when thinking about architecture. So for all these things, we're currently working on creating a framework that would actually help you understand better and have all these checkboxes that you need to tick before deciding on how to continue. For now, it's just something to lead you and something to think about when deciding on the way you will implement the software. And finally, I want to leave you with this single thing. It's if there's only one thing that you take away from this talk, it should be that software design principles are your tools, they're not your goals. So you should always strive to use them to achieve your goals instead of trying to achieve them as an end goal. Thank you.
Okay, thank you also from my side. Was a good talk. Thanks for that. We don't have so many questions. One is, if you build something quickly in the beginning, isn't there a high risk that you won't have enough time and motivation to improve it later?
Well, again, it depends. So these are some things that usually come with experience. It's not that you have a single rule that applies to all of it. Basically, if it's something like in our example that you're not sure that you will need to come back to it later, just make it simple and think about coming back to it and refactoring after you need to extend it with another thing. If it's something that you're certain that you need to redevelop and extend at a later point, that definitely spend some more time in the beginning, because it would cost you a lot of motivation afterwards to just come back and adjust it.
So it's also a cultural thing, maybe, if the company supports it enough, or if they just say, oh, it's running, it works somehow.
Yes, exactly.
Okay. Cool. Then there's another question. Can I combine time-driven development with test-driven development or domain-driven development?
Of course. I mean, this is it's not something that you should use as a single thing. It's just a kind of like a guide to guide you when you need to apply all these other best practices, all these other processes, and understand whether you need to use everything else or not. So sometimes when you're building an MVP or something that just maybe your client or yourself want to test something out with the users and then go back to it and re-implement everything, maybe it doesn't make that much sense to start with test-driven development. Maybe it does. Again, it's the context of your own project, and it's something that you should think about upfront to understand how to proceed.
Okay, maybe one last one. It's I just checked. It's also updated in the app. The question is not the point of design principles that they should create simple code?
Can you repeat the question?
Yeah, if the design principles don't have the purpose to create simple code, so I think the assumption is that if you always use the design principles, that your software will be simple.
You will have a good code?
Yeah, I think that's the idea behind it.
You would, but sometimes, I mean, I found myself going through all this overcomplicated code just by applying all these principles, and then it was harder for me to understand. So the purpose of the design principles is to create a better developer experience. If the app is so simple that all these principles are making things more complex for you and more harder to understand, then the developer experience is not that good. And again, we have a principle like Solid, and we have a principle like Yagni, for example, where it states that the actual name is you ain't gonna need it. So think about what principle is the proper one to follow at a certain point.
Okay, let me just check. There's another question, but that's very much into detail. So, but I will nonetheless ask it because. Yeah. So, why would you also wouldn't you also do the string splitting for the skills inside the model of the repository? I'm not sure. It's probably about one specific slide.
Oh yeah, probably.
So I think we can skip that one. Or it's just a detail.
Maybe we can discuss it afterwards. Find me outside.
Cool. I think that's it for now from the questions. So thanks again.
Thank you.